This is SpaceTime Series 22, Episode 26. Coming up on SpaceTime. Could mysterious fast radio bursts be magnetars? Earth's biggest meteor blast since the 2013 Chelyabinsk event. And Genesis grabs the moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a highly magnetic neutron star called a Magnetar, which appears to have a lot of the characteristics of those mysterious high-energy pulses known as fast radio bursts. Neutron stars are created when very massive stars, far larger than the Sun, reach the end of their lives and explode in powerful events known as core collapse supernovae. What's left behind is a highly compacted superdense stellar corpse, so tightly squashed that all the positively charged protons and negatively charged electrons are literally crushed together to form neutrons, hence the star's name. Although only a dozen or so kilometres wide, neutron stars are the densest objects in the universe other than black holes. Fast radio bursts are mysterious sudden high-energy flashes at very specific wavelengths, lasting just nanoseconds and originating at cosmic distances. Most are singular events, occurring just once at a specific location in space, and then never again. That suggests they're probably caused by some sort of cataclysmic event, such as a supernova. The problem is there have been several fast radio bursts which have repeated, and these appear to originate from near the centres of galaxies. And the speculation suggests they're caused by the supermassive black holes that reside there. Now, scientists with Caltech and NASA's Jet Propulsion Laboratory in Pasadena, California, have analysed fast radio burst-like pulses coming from what appears to be a magnetar located near the supermassive black hole at the centre of the Milky Way galaxy. One of the study's authors, Aaron Perlman from Caltech, says these observations are showing that radio magnetars can emit pulses with the same characteristics as those seen in some fast radio bursts. The authors were studying a magnetar named PSR J1745-2900. It's located near Sagittarius A star, a supermassive black hole at the centre of our galaxy, some 26,000 light-years away, with a mass of some 4.3 million times that of the Sun. PSR J1745-2900 was initially spotted by NASA's Swift X-ray Space Telescope. It was later determined to be a magnetar by NASA's NuSTAR, or Nuclear Spectroscopic Telescope Array spacecraft. That was in 2013. Magnetars are a rare subtype of a group known as pulsars. Pulsars, in turn, are rapidly spinning neutron stars. Magnetars are thought to be very young pulsars which are spinning more slowly than ordinary pulsars and have much stronger magnetic fields, which suggests that perhaps all pulsars go through a magnetar-like phase during their lifetime. PSR J1745-2900 is the closest known pulsar to the supermassive black hole at the centre of the galaxy, separated by a distance of just 0.3 light-years. And it's the only pulsar known to be gravitationally bound to the black hole and the environment around it. All of this has allowed scientists to use this magnetar to help probe the conditions and environment near the Milky Way's supermassive black hole. In addition to discovering similarities between the galactic centre magnetar and some fast radio bursts, the authors also gleaned new details about the magnetar's radio pulses. Using one of NASA's Deep Space Network's largest radio antennas, located at Tidbinbilla near Canberra in Australia, scientists analysed the individual pulses being emitted by the star every time it rotated, a feat that's actually pretty rare in radio studies of pulsars. They found that some pulses were stretched or broadened by a larger amount than what was predicted when compared to previous measurements of the magnetar's average pulse behaviour. Furthermore, the behaviour varied from pulse to pulse. Speaking at the 233rd meeting of the American Astronomical Society in Washington, Perlman says he was seeing these changes in the individual components of each pulse on very fast timescales. And the behaviour is really unusual for a magnetar. The radio components are separated by only 30 milliseconds on average. Now, one theory to try and explain the signal variability involves clumps of plasma moving at high speeds near the magnetar. Perlman and colleagues suggested the movement of these clumps could be the actual cause of the observed signal variability. Another theory proposes that instead of something happening to the magnetar, the variability is intrinsic to the magnetar itself. Perlman says understanding this signal variability will help future studies of both magnetars and pulsars at the centre of the galaxy. Perlman and his colleagues are also hoping to use the Deep Space Network dish to solve another outstanding pulsar mystery, namely why there are so few pulsars near the galactic centre. Their goal is to find the non-magnetar pulsar near the galactic centre black hole. Perlman says finding a stable pulsar in a close gravitationally bound orbit with Sagittarius A star could prove to be the holy grail for testing theories on gravity. If they find one, they'll be able to do all sorts of unprecedented tests of Albert Einstein's general theory of relativity. I'm Stuart Gary. You're listening to Space Time. The Earth's been hit by its biggest meteor blast since the 2013 Chelyabinsk event in Russia. The meteor airburst over the Bering Sea late last year in a sparsely populated region off the east coast of Russia's Kamchatka Peninsula. The December 18 event's being described as a large fireball. That's the term astronomers use for exceptionally bright meteors visible over a wide area. The meteor exploded as it slammed into the thicker atmosphere about 26 kilometres above the planet's surface. The explosion unleashed an estimated 173 kilotons of energy. That's more than 10 times as powerful as the bomb dropped on Hiroshima to help end World War II. Military satellites designed to look for nuclear explosions picked up the blast, as did more than 16 infrasound detectors around the globe. 2 NASA instruments aboard the Terra satellite, as well as sensors aboard Japan's Himawari 8 weather satellite, which is partially funded by Australia's Bureau of Meteorology, also captured images of the blast. NASA's image sequences show views from 5 of the 9 cameras on the multi-angle imaging spectroradiometer. The instrument took the shots at 23:55 Greenwich Mean Time, just moments after the event. Both the Terra and Himawari 8 images show the meteor's trail through Earth's atmosphere casting a shadow on the cloud tops, elongated by the low angle of the sun. They also show an orange-tinted cloud of smoke left behind by the meteor as it ionized the air as it was passing through. Fireball events are actually fairly common, and they're recorded in the NASA Center for Near-Earth Object Studies database. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
That explosion in December, what happened?
It went bang.
Yeah, I'm sure it did. Would have been a mighty loud bang, I imagine.
And that's how we know about it, actually. You're quite right. This is an event that took place on the 18th of December, but it's only hit the headlines within the last few days. So where are we? We're exactly 3 months down the track. And the main reason why that is the case is because nobody saw it.
Well, it's a pretty isolated part of the world, is it?
That's
not?
right. So this was over the Bering Sea. It's a place called the Kamchatka Peninsula, which is part of Russia and a very uninhabited part of the world.
Well, let's face it, if they saw it, they wouldn't have told anyone anyway.
Who knows? They might have wanted to keep it to themselves. That's right. It's an event that we now know was comparable, although less intense, than the Chelyabinsk meteor. That was an object that entered the Earth's atmosphere above the city of Chelyabinsk in the Ural Mountains, also in Russia, back in 2013. And it caused an explosion which, if I remember rightly, was the equivalent of 450,000 tons of TNT. It was many times the Hiroshima nuclear explosion. And it was caused by an object about 30 meters in diameter, hitting the Earth's atmosphere at something like 20 kilometers per second. It blew up in the morning sky above Chelyabinsk and created a flash 30 times brighter than the sun, which everybody rushed to their windows to see what had happened. And 88 seconds later, the blast wave hit the ground, smashed all the windows, and many, many people wound up in hospital. Something like 1,200, I think,
Yes.
in Chelyabinsk.
And I take back what I said about the Russians, because I've never seen more footage of one event in my life,
Exactly.
entire life.
They are right on the ball there. That's right. It's all dash cam footage.
Yes.
That's the last big, what you might call a super bolide. That's the technical term for this, a super bolide, where something hits the atmosphere and explodes like that. Very big one and clearly very significant. And it's actually very fortunate that nobody lost their life in that because, walls were blown down and things of that sort. So this event, as I said, it's comparable. It was probably about half the impact of the Chelyabinsk one. The explosion is being categorized at about 173,000 tons of TNT, still 10 times the Hiroshima nuclear weapon. But that means it is really less than half the one that entered over Chelyabinsk.
But still a mighty big explosion.
Yeah. How do we know it happened? if nobody saw it? And the answer is because the world is festooned with what are called infrasound detectors. These are detectors that pick up sound waves which are at a much, much lower frequency than we can hear, but actually permeate through the atmosphere. And in the case of the Chelyabinsk event, the infrasound went twice around the world.
Wow.
And it sort of reverberated for most of the rest of the day. And it was picked up by 20 infrasound monitors. It was the biggest infrasound signal that had ever been detected. Now, this one is not as big as that one, the Bering Strait explosion, but it was the infrasound that actually revealed its existence. And that was then followed up by sort of a few space enthusiasts, one of whom picked up an image of it entering the Earth's atmosphere. There is basically the explosion can be seen on an image from a Japanese weather satellite, which sits in a geostationary orbit over that part of the world. The Japanese weather satellite recording the surface of the Earth and the cloud cover and all of the rest of it. It was actually a meteorologist who trawled through the data from the Himawari 8 satellite is the one that it came from, and it's run by the Japan Meteorological Agency. Simon Proud, he's a meteorologist and actually works at the University of Oxford. So he did have the academic resources necessary to do that, but he did find an image from this satellite that shows a nearly vertical sort of orange streak. And that ties in with the infrasound measurements, which suggest that this thing came in almost vertically, an angle probably about 7 degrees to the vertical.
Wow, that's pretty steep. So it hit us broadside, basically.
Yeah, that's right. And something like 10 meters across, a mass of about 1,400 tons, and the explosion, as I've said, was picked up by these various infrasound detectors. So really quite an extraordinary thing. If you look at the airbursts of these small asteroids, I guess is what you call them, a few meters across, over the last 100 years, there have been 3 of them. One was the Tunguska event in 1908. Then there was the Chelyabinsk one. The Tunguska was far more powerful than any of the other 2.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Israel's first mission to land on the moon is continuing nominally, despite an early glitch with the spacecraft's navigation system. The issue caused an involuntary reboot and delayed a planned 4-minute engine burn by 2 days. Mission managers with SpaceIL say all systems are operating nominally and the mission is continuing as planned.
Hi, Jonathan from Team SpaceIL here. I'm standing in Israel and I'm really excited to tell you all about the important maneuver that we just had and why was it so difficult. So we launched the spacecraft into orbit and we shared a ride with another satellite. So that means we're not in a trajectory to the moon yet. We have to do orbit correction maneuvers in order to get to the moon, and this is something we expected a long time ago. The problem with making orbit correction maneuvers is because we had some sort of an issue with the star tracker, and that was not trivial that we can actually do this, and that was a huge success. And I want to take you back and tell you about why it was difficult and what's so hard about it. So first, a star tracker is a type of a camera just like the one you have on your phone, and it takes pictures of the stars, and this is how we know where we're aiming, where the engine goes, and where should we fire. The problem is, like cameras, if you shoot them towards the sun, they get blinded. So we have some sort of a visor that's supposed to help it from happening, but something went wrong, we're still not sure why, and we get blinded in angles that we did not expect. So the sophisticated engineers in the team worked actually all night to try to figure out an angle or configuration that will make it all work, and we can actually make the maneuvers, because if the star tracker is blind, we don't know where the engine is aiming, and there's a real risk of losing the spacecraft. So they worked all night, and they uploaded a command. I was talking to the engineer Lior, and she was about to upload the command, and I asked her like, what does she feel? And she told me, it's not a big deal, we practice it a lot, but still there was a lot of tension in the control room, and we all waited for this critical moment, and that was a huge success. And the maneuver was corrected very nicely, and we're now in orbit. There's going to be another correction maneuver that's going to be 10 times longer, so it's actually a lot more risk, so we're still holding our fingers for a successful maneuver correction. Thank you so much.
If successful, Israel will become only the fourth nation on Earth after the Soviet Union, the United States and China to undertake the 384,000-kilometre journey to land on the lunar surface. The mission also comes 50 years after America's historic Apollo 11 lunar lander, where Neil Armstrong and Buzz Aldrin became the first men to walk on the moon. Israel's Genesis lunar lander blasted into orbit on February the 22nd aboard a SpaceX Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida. The 585-kilogram Genesis, or Beresheet in Hebrew, was successfully deployed into orbit 35 minutes after launch, igniting its own onboard rocket engines for the first of several times to progressively increase its orbital apogee, or furthest distance from the Earth, until the orbit is so large it also encompasses the Moon. Using this process known as orbital raising instead of a more direct lunar transfer maneuver has become the preferred method of reaching the Moon for robotic missions which aren't time-sensitive. That's because it uses less fuel, but of course, as I said, it's not time sensitive. It takes about 7 weeks rather than just 3 days. Once it gets there, the spacecraft will undertake a lunar orbit insertion maneuver, eventually going into orbit around the Moon for up to a month, before landing on the Mare Serenitatis, or Sea of Serenity, a 674-kilometre wide dark basaltic lunar basin, just east of the Mare Imbrium. Once on the lunar surface, Genesis will send back video and images and use its magnetometer to study the lunar magnetic field to help scientists better understand how the Moon formed and evolved. It'll also deploy a laser retroreflector array on the lunar surface for NASA as part of a new lunar base navigation system. It's hoped NASA's Lunar Reconnaissance Orbiter will be in position to document the spacecraft's descent and landing on the Moon's surface. And NASA's Deep Space Communications Network is providing telemetry and communications for mission managers in Tel Aviv. As well as its primary scientific payload, Genesis is also carrying a digital time capsule known as the Arch Lunar Library, which contains over 30 million pages of data, millions of documents from around the world, including dictionaries and encyclopedias, a full copy of the English language Wikipedia, a copy of the Judeo-Christian Bible, examples of fine literature and art, as well as children's drawings, memories of a Holocaust survivor, Israel's national anthem, the Hatikvah, an Israeli flag, and a copy of the Israeli Declaration of Independence. You're listening to Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that consuming even moderate amounts of high fructose corn syrup, a common ingredient in sugary drinks, enhanced intestinal cancer tumour growth. A report in the journal Science claims previous research has suggested that high fructose corn syrup could contribute to cancer because it causes obesity, and obesity increases cancer risk. But the new work suggests that high fructose corn syrup increased tumour growth independently of obesity. That's because the tumours convert it directly into substances that help them grow. A new study claims alcohol isn't just bad for drinkers, but also for the people around them. A report in the journal BMC Medicine claims most research into alcohol-associated harms focused on the harm to the drinker, not others. So the authors of the new study estimated the harms caused to others by alcohol during pregnancy, in road traffic accidents, and as a result of interpersonal violence. They found alcohol was responsible for 45.1% of third-party road traffic deaths, 14.9% of interpersonal violence-related deaths, and almost 16,000 cases of fetal alcohol syndrome and fetal alcohol spectrum disorders. The researchers say the findings highlight the need to consider the bigger story around alcohol, not just individual health. Well, I guess it's fair to say we all enjoy a little bit of couch time after a hard day at work, but Northern Irish researchers say that all that excess time lounging around is linked to around 50,000 deaths per year in the United Kingdom, as well as putting a huge strain on the UK's National Health Service. A report in the journal Epidemiology and Community Health found that a third of adults in the UK spend at least 6 hours sitting down during the week, and that number increases over the weekend. Sedentary behaviour has previously been linked to increased risks of heart disease, type 2 diabetes, cancer, and deaths from all causes. There are new warnings out today that if the current rate of illegal deforestation in Brazil continues, it could increase the land surface temperature by up to 1.45 degrees Celsius in some areas by 2050. The report in the journal PLOS ONE is based on data modelled on how land surface temperature changes when forests are cleared. It looks at the amount of sunlight reflected off the Earth and the amount of water vapour released from plants into the atmosphere. Researchers say that in tropical forests such as in Brazil, clearing causes a local warming, while planting has a cooling effect. Technology developed by the University of New South Wales could provide an environmentally friendly, cost-effective method of sterilising water. The new technology bubbles unpressurised carbon dioxide through wastewater in a bubble column, effectively inactivating both bacteria and viruses. Researchers say the new technology is capable of sterilising water with hot CO2, which considerably reduces energy requirements when compared to boiling water, as heating gas is much more efficient than heating water. A new study suggests that rogue waves are occurring less often but becoming more extreme. The findings, published in the journal Scientific Reports, are based on long-term data from a wide expanse of ocean to investigate how these rare, unexpected and hazardous ocean phenomena behave. Waves are classified as rogues when they're over twice the height of the average sea state around them. From trough to peak, past observations have put some rogues at over 30 metres in height. The fiercest are capable of damaging or even sinking ships, and on occasions have swept people off the shoreline and out to sea. The data came from 15 buoys which provided surface information along the US western seaboard, stretching from Seattle in the north down to San Diego in the south. The data showed that instances of rogue waves across the 2-decade window fell slightly, but it also showed that rogue wave size increased. Scientists also found that rogue waves are more prevalent and of greater severity during winter months, and intriguingly are happening with increasing frequency during calmer background seas. A new study has confirmed the famous Dunning-Kruger effect in action. It's found that the most extreme opponents of genetically modified foods actually know the least about the science, but at the same time they genuinely believe they know the most. The findings are based on surveys conducted in the United States, France and Germany. Tim Mendham from Australian Skeptics says the findings suggest that rather than being a barrier to the possession of strongly held views, ignorance of the facts might better be described as the fuel.
The Dunning-Kruger effect says people are not aware of how little they know. People often overestimate what they know because they want to impress other people. With the GM foods, there's a survey done about genetic modification of foods, and they ask people a whole range of different people in a survey, their information on science, how much they know about science, so some basic questions like do plants give out oxygen and that sort of stuff. So it's pretty ordinary stuff. And they found that a lot of people who are really opposed to it don't know much about science, and that they have a great deal of confidence, though, at the same time, in what they think they do know.
Of course, the problem there is you label something as Frankenstein food or something like that, and labels like that stick, and people are going to err on the side of caution, even if it's not necessary.
There have been genetically modified foods around for a long time, but it's only if they're sort of recognised and made a big fuss about that people get worried about them. But this issue is that those who are most strongly opposed, now this is probably a pretty overgeneralisation, but a lot of people who are strongly opposed to GM foods are also fairly ignorant of the science behind it. It's an emotional response to a lot of people.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.